Good morning, dear students. This is part 6 of chapter 10, that is gravitation. In this part, I'll solve some questions of exercise of this chapter. After that, you will try to solve some questions by yourself. Okay, so let me start. The first question from your exercise is how does the force of gravitation between two objects change when the distance between those two objects is reduced to half? Okay, if the distance between two objects is reduced, how does the force of gravitation will change? So here is the solution. See, this is the formula. The force of attraction between any two bodies can be found out by using this formula. And in this formula, F is equal to G m1 m2 upon r square. m1 and m2 are the masses of two bodies. G is the gravitational constant, r is the distance between the two bodies, and see, in question it is given that r will be reduced by half, means r will be half of the earlier value. See, these are two objects, objects 1 and objects 2. They are separated by a distance r. Okay, the mass of this object is m1 and another is m2. The distance is r. So if the distance is reduced by half, if the distance is reduced by half, r by 2, then what will be the value of f? That we have to find out. m1 and m2 are not going to be changed anyhow. Okay. So now use the same formula. F is equal to G m1 m2 upon r square. Now what we are going to do here? We just have to substitute the value of r. So F is equal to G m1 m2 upon r by 2 ka whole square. See, the value of r is r by 2. Okay, so now open the whole square and we will get F is equal to 4 G m1 m2 upon r square. So you can see that F is equal to 4 F1. This is F1, this is F1. If you compare this equation, equation number 1 and equation number 2. So comparing these equations, you can see that F is 4F1. So once the distance between the objects is reduced to half, then the force of gravitation will increase by 4. Okay. Second question is, gravitational force acts on the objects in proportional to their masses. Why then a heavy object does not fall faster than a lighter object? Okay. So here is the answer. All the objects fall towards the earth with a constant acceleration, and that is acceleration due to the gravity. It is denoted by g. The value of g does not depend on the mass of the object anyhow. See, here is the formula and you can see the value of g is directly proportional to the mass. This is the mass of the earth and g is inversely proportional to the mass, to the radius, to the square of the radius of the earth. Okay, and this value of g is constant. So acceleration due to gravity depends on these two things, mass of the earth and radius of the earth. It doesn't depend on the mass of the object, and that is why heavier objects do not fall quicker than the lightweight objects, with one condition, that there should not be any air resistance. So in the absence of air, both the objects will fall on the earth at the same time. Okay. The next question is, what is the magnitude of the gravitational force between the earth and 1 kg object on its surface? And to solve the questions, the value of mass of the earth is given to you and the value of radius of the earth is also given to you. Okay, so let me solve this question to you. This formula, you know, F is equal to G m1 m2 upon R square. Okay, and m1 is given to you. The value of m1 is 6.0 into 10 to the power 24 kg. Fine. The value of m2 is also given to you. That is 1 kg. Fine. Now, the value of R is radius of Earth. That is distance between two bodies. Okay. If this is Earth, so the body is considered over here, and this is the center of the Earth. So the radius of the Earth is the distance between these two objects. Okay, and as you know, the value of G is always constant, that is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. Now you have to do one thing only, you have to substitute all these values in this formula. So on solving this, we get the value of F, that is 9.8 Newton. Okay, so it shows that Earth exerts a force of 9.8 Newton on the body of mass 1 kg. The body will exert an equal force of attraction of 9.8 Newton on the Earth. Okay, here is question number 10 from your exercise. Let me read the question for you. It says Amit buys few grams of gold at the poles, and he hands over the same when he meets him at the equator. Okay, at the poles Amit is buying some gold, and the same gold he is handing over to his friends at the equator. Now the question is, will the friend agree with the weight of the gold? If not, then why? Okay, to solve the question, hint is also given to you, and the hint is the value of G is greater at the poles than the equator. Would you like to know why it is like that? See, let me draw the shape of the earth. Earth is somehow like that. It is not perfect square, and at the equator the diameter is more, hence the radius of the earth is more, and on the poles the diameter is less, so its radius will also be less. Okay, see, this is the formula to find out G. The value of G depends on mass of the earth and on radius of the earth. So G is inversely proportional to the square of the radius of the earth. If radius of the earth is more, the value of G is less. If radius of the earth is less, the value of G is more. Fine. So you can see it clearly over here. The value of R is less at the poles. So if R is less at the poles, G is greater at the poles. Okay. And when R is more at the equator, G will be less at the equator. The same thing is explained over here. The value of G is more at the poles. So if G is more, so weight will be more. Why? Because W is equal to mg. And if the value of G is more, W will be more. Value of G is less at the equator, so gold can weight less at the equator as compared to the poles. So his friend will not be agree with the weight of the gold bought by Amit. Fine. Here is the 30 number question. What is the question? Let me read it for you. Question says that a ball is thrown vertically upward with a velocity of 49 meter per second, and you have to calculate the maximum height to which it rises, and then you have to find out the total time it takes to return to the surface of the earth. Okay, fine. See, ball is thrown in upward direction. This is ball and this is thrown in upward direction. Okay, and after that it will start falling down. So you have to find out the maximum height, and then you have to find out the time it takes to return to the earth. Okay, so at first let me collect the data given in the question. What is given over here? Initial velocity of the ball is given, that is 49 meter per second. Fine. And see, final velocity will be 0. Why? Because after reaching a height, the velocity will become 0. Then only it will start coming down. And acceleration is g is equal to minus 9.8 meter per second square. Do you know why it is minus? Because ball is thrown in upward direction. That is why the value of g is taken as negative. Now here we will use third equation of motion. And this is third equation of motion. V square is equal to u square minus 2gs. See, this minus is due to the direction. The ball is thrown in upward direction. That is why the value of g is minus. Now you just substitute the value of u, v and g in this equation and we will get this. 0 is equal to 49 square, value of e 2, g and s. And from here we will get the answer. S is equal to 122.5 meter. So ball will travel or cover this much height. Fine. Now come to the next point. This is the next point. Now we have to find the total time. See how much time will be taken. The time taken by the ball to ascend and the time taken by the ball to come down. And to find out this, we will use first equation of motion. V is equal to u minus gt. Again, we have taken g as negative. So after substituting the value, we will get t is equal to 5 seconds. Okay. And then 5 seconds in coming down. So total t will be 10 seconds. Okay. So the ball will cover 122.5 meter before it start coming downwards, and the total time taken by the ball is 10 seconds. Now we come to question number 14. The question is, a stone is released from the top of a tower of height 19.6 meter. You have to calculate its velocity just before touching the ground. Okay, the stone is thrown or released from the top of a tower. Okay, so when it is released, at that time u will be 0 and height is given 19.6 and g is 9.8 meter per second square. Fine. Now we will use third equation of motion. V square is equal to u square plus 2gs. V square is equal to 0 because u is 0, then 2g and s means distance, and distance is, in this case, the distance is height covered over here. Okay, so height is 19.6. So now we'll get v square is equal to 384.16 and v is equal to 19.6 meter per second. So that will be the velocity of the stone just before touching the ground. Question number 21. What does it say? It says that the volume of 50 gram of substance is 20 centimeter cube. If the density of water is 1 gram per centimeter cube, will the substance float or sink? Okay, you have to answer whether the substance will float or sink. So to find out this, you are supposed to know what is the density of the fluid and what is the density of the substance. Okay, so density of the water is given, but density of the substance is not given. That we will find out. How to find out? Okay, here is the solution. The density formula to find out the density is equal to mass upon volume. Okay, so density of the substance is mass of the substance upon volume of the substance. That is 50 gram upon 20 centimeter cube. So answer will be 2.5 gram per centimeter cube. And density of the water is given over here in the question itself, 1 gram per centimeter cube. So now you are having density of substance and density of water. Both the densities are with you. See, density of the substance is greater than the density of water, that you can see clearly. It is 2.5 and that is 1 gram per centimeter cube. So what will happen? substance will sink into the water. Okay. So, dear students, this much was all for this session. I solved some questions for you. Here are some questions in exercise. Try to solve all these questions by yourself. Okay. And see if you are not able to solve the question. We will solve your doubts in video session, but do one thing. Keep your fair book with you so that you can tell me that at which point you could not solve the question. If you know your doubts, then only you can solve them properly. Okay. So now thank you students. Now we'll be meeting with a new chapter in video lectures. But in live class, I'll be solving your doubts for this exercise. Thank you.